this video, we are going to learn how to divide polynomials using long division. But how do we execute long division? The technique of long division follows 5 steps. We divide, we then multiply, subtract, bring down, and then repeat or register the remainder. Suppose we are tasked to divide 67 by 4 using long division. We will have the long division symbol this, the divisor here, and the dividend here. We start by dividing the divisor into the first digit or digits of the dividend. Yes. So we have 6 divided by 4. What do we get? One whole number, remainder 2. We write the whole number here and we ignore the remainder for now. Then we proceed to multiplication. We multiply the divisor by the number we've just placed in the quotient. So we have 1 times 4, which is the same as 4. We then subtract the result from the current digit of the dividend. So we have 6 minus 4, which is the same as 2. We then proceed to bring down. What do? We bring down the next digit or digits of the dividend to create a new but a smaller number. In this case, it will be 27. We then repeat all the steps until all the digits are used. And if a number that cannot be divided further remains at the end, it is the remainder. So we will have 27 divided by 4, which is the same as 6 whole number, remainder 3. We write the whole number in the quotient and then ignore the remainder for now. Then we multiply 4 times 6, we get 24. Then we proceed to subtraction. 27 minus 24. 2 minus 2, we get a 0, and 7 minus 4, we get 3. Since this can't be divided further, by default it is the remainder, and this is the divisor, this is the quotient Q, and this is the dividend P. The quotient equals to 16 and the remainder equals to 3. Yes. The divisor is 4 and the dividend P equals to 67. But from the division algorithm equation, the dividend P should equal to the product of the quotient and the divisor times the quotient plus the remainder. But is this true? Let's test it using values from this our problem. So we will have P equals to 67, the dividend equals to the divisor 4 times the quotient 16 plus the remainder 3. 4 times 16 is the same as 64. 4 times 16 same as 64. So we have 67 equals to 64 plus 3. And 64 plus 3 same as 67. So we have 67 equals to 67. And since the left-hand side equals to the right-hand side, then this equation is true. But we will be using this in remainder theorem and also to prove whether the results of dividing polynomials are true. So this is the basic way we perform long division. But the main aim of this video was to divide polynomials using long division. So let's have some examples. Example 1, divide the polynomial x cubed minus 3x squared plus 6x plus 5 by x minus 2. So we are given a polynomial x cubed minus 3x squared plus 6x plus 5, and the divisor, which is x minus 2. And we are required to divide this polynomial by this divisor using long division. So we have a long division symbol, this, a divisor x minus 2, and a polynomial, which is our dividend, x cubed minus 3x squared plus 6x plus 5. The key point to note is that the process of long division for polynomials is analogous to that of the integers. So it will follow the same steps: divide, multiply, subtract, bring down, and repeat, or register a remainder. And to go about this, we identify a term in this dividend, our polynomial, with a variable raised to the highest power, which is this. And we do the same for the divisor, which is this. We then compare, is the power of this greater or equal to the power of this? If yes, we proceed with this process of division. If no, we terminate the division. So we will have the whole term, which is x cubed, divided by this term x. What do we get? We get x squared using indices. 3 minus 1. We get x squared. We then write it in the quotient, which is x squared. We proceed with the multiplication. What do we have? We have x squared times x minus 2. We have x squared into x minus 2. We multiply this current digit in the quotient with the divisor. So we have x squared times this. What do we get? X squared times x, we get x cubed, and x squared times negative 2, we get minus 2x squared. We then proceed to subtraction. We will have this polynomial minus this. What do we get? We have something like x cubed minus 3x squared plus 6x plus 5 minus x cubed minus 2x but squared. What do we get? This becomes a negative, it cancels with this. So x cubed minus this, we get 0. And negative 3x squared minus negative this, we have negative 3x squared minus negative 2x squared. This becomes a positive, and this is a negative, so we remain with negative x. This is minus x but squared. And the same applies to this. 6x minus 0x, we get plus 6x, and 5x to power 0, or a constant, minus nothing, we get plus 5. Like terms. At this stage, we have minus x squared plus 6x plus 5. We then identify the term with the variable having the highest power, which is this. And we compare with this variable. Is it greater or equal to? Yes, it's greater. So we proceed with a division. Negative x squared divided by x. What do we get? We get, this is negative x squared divided by x. We get negative x. So we write it here. It becomes a minus x. We then multiply. We proceed to multiplication. Negative x times x, we get negative x but squared. In negative x times negative 2, we get a positive 2x. We then proceed to subtraction. This minus the whole of this. What do we get? Negative x squared, we have negative x squared minus negative x squared. This becomes a positive and they cancel out, so we remain with a 0, and 6x minus 2x, we get 4 plus 4x, and 5 minus nothing because we don't have any constant here, we will have plus 5. So we have 4x plus 5 as our new dividend. Is the power of this variable greater or equal to that of this? Yes, they are equal. So we proceed with the division. We will have 4x divided by x. This cancel will remain with a 4. And we write here a 4 in our quotient. Then we proceed with the multiplication. 4 times x, what do we get? We get 4x. And 4 times negative 2, we get minus 8, negative 8. Then we proceed with the subtraction. This minus that. What do we get? 4x minus 4x, we get a 0. And 5 minus negative 8, what do we get? 5 minus negative 8, this is a positive, we remain with 13, which is plus 13. But remember, constants are coefficients of variables raised to a power of 0. So this is the same as 13x, but raised to a power of 0. Is the power of the variable in this term greater or equal to the power of the variable in this? No. So we terminate the whole process. And by default, this will become a remainder. Whereas this is the divisor and this is the polynomial of x, our dividend, and this is the quotient of x. But from this our problem, we were tasked to divide this polynomial by this divisor. We can even use the division algorithm equation to prove whether our answer is correct. Let's do that. From the division algorithm equation, what do we know? We know that the polynomial of x should equal to the quotient of x times the divisor of x plus the remainder. Our quotient of x equals to x squared minus x plus 4. And our divisor of x equals to x minus 2. The polynomial of x equals to x cubed minus 3x squared plus 6x plus 5. And our remainder equals to 13. Let's try to feed this information into this and see whether the left-hand side will balance with the right-hand side. Just to test. Let's substitute for this information in this division algorithm equation. We have our polynomial, which is x cubed minus 3x squared plus 6x plus 5. And our divisor, the product of the divisor and the quotient, our divisor is x minus 2 times our quotient, which is x squared minus x plus 4. Then plus the remainder, which is 13. The left-hand side will remain the same, so we will have, let's try to open these brackets. X times x squared, we get x cubed, and x times negative x, we get minus x but squared, and x times 4, we get plus 4x. Same applies to this. Let's multiply this. Negative 2 times x squared, we get minus 2x but squared. In negative 2 times negative x, we get positive 2x. In negative 2 times 4, we get negative 8 plus 13. This is the same and this is the same. So we have x cubed, we only have one x cubed, so we have x cubed, x squared, and x squared, we get negative 3x squared, x to power 1, and x to power 1, we get positive 6x. Then also constants, negative 8 and 13, we get plus 5. Since we have x cubed minus 3x and 6x plus 5, which is the same as this, the left-hand side equals to the right-hand side. So our solution is correct. With this being our polynomial, we've divided. This is our divisor, and this is our quotient of x, and this is the remainder of x, which implies that if we divide this our polynomial, x cubed minus 3x squared plus 6x plus 5 all over our divisor, which is x minus 2, we will get x squared minus x plus 4 plus the remainder, which is 13, all over the divisor, which is x minus 2. This will be the solution to this our problem. Okay, example number 2. Find the remainder when a polynomial x cubed plus 5x minus 2 is divided by x squared minus 3x plus 2. So we are given a polynomial of x which equals to x cubed plus 5x minus 2 and the divisor of x which equals to x squared minus 3x plus 2. And we are required to determine or find the remainder. To go about this, we will have a division symbol with a divisor x squared minus 3x plus 2 and the polynomial of x to power 3 plus 5x minus 2, which is our dividend. But remember, just like long division for integers, this will also follow the same steps. We divide, multiply, subtract, bring down, and then repeat or register a remainder. Is the power of this greater or equal to the power of this? Yes. So we will have x cubed divided by the term in this, x squared, and we will have x indices, which is 3 minus 2. So we will write x in the quotient, then we proceed to multiplication. X times x squared, what do we get? X cubed. And x times negative 3x, we get minus 3x squared. Then x times 2, we get plus 2x. Then we proceed to subtraction. This dividend minus this. What do we get? X cubed minus x cubed, we get a 0. And 0, since we don't have a term in x squared in this, minus negative 3x squared, we get positive. This is plus 3x squared. And 5x minus 2x, we get plus 3x. Then also negative 2 minus nothing, which is the term in x to power 0, we get negative 2. We then repeat the process. Is the power of this greater or equal to the power of this? Yes, they are equal to each other. So we have the term in this, which is 3x squared all over this term, which is x squared. This cancels with this, we remain with 3. We then write 3 in the quotient, positive 3. Then we proceed to multiplication. 3 times x squared, same as 3x squared. And 3 times negative 3x, we get negative 9x. And 3 times 2, we get positive 6. And plus 6. Then we proceed to subtraction. This dividend, the new dividend, minus this, what do we get? 3x squared minus 3x squared, we get a 0. And 3x minus negative 9, we get a positive 12. Plus 12x. And negative 2 minus positive 6, we get negative 8. We then check again. Is the power of the variable in this term greater or equal to the power of the variable in this? No. This is raised to a power of 1 and this is raised to a power of 2. So we terminate the division process. So by default, this will become a remainder, whereas this is the divisor. This is the polynomial of x, our dividend, and this is the quotient of x. But we are tasked to determine the remainder, which implies that, let's conclude, therefore, if we divide this polynomial, our dividend, by this divisor, we will get a remainder of 12x minus 8.